This is Bits and Pieces, the official podcast of Component Supply. I'm Kristin.
And I'm Mark.
And today we are going to be taking you through some of the challenges that we see when customers ask for hypodermic tubing or a wire that has some sort of bend configuration on it. This is something that we routinely do, that we are trying to advise customers how to make their part cost effective, how it can scale. Because again, we're at the very beginning stages of R&D for these medical device components. And so a lot of times what is possible for 1 to 10 pieces might not be favorable or wise when you scale up. So we try to catch that really early on so we can advise on that. But there are certain challenges that we get. We joke sometimes that just because SolidWorks will produce it, just because you can have it on a drawing doesn't mean it works out practically. And so a lot of the challenges we see come from customers who are requesting a bend radius that's essentially too tight. For those of you who don't know, Mark is the president of Component Supply and is very hands-on in our shop. And so every day we are reviewing drawings and bend configurations and taper profiles that come across our desk. If it's something we haven't seen before from a customer, we have a meeting with production, we have a meeting with sales, and we try to put together a plan to get you these parts as quickly as possible, as efficiently as possible. And so Mark is really going to be the engineer here for us today. So we talk to you. We get these drawings, and sometimes you look at it and say no. Of course, we generally don't tell the customer no right away. We try to make some provisions or allowances or give them some insights. So when we talk about bend radius, what are the challenges that you see when we send something to you?
And when I say no, it's usually, you're looking at it and it's like no in its current state.
Sure.
That's what happens. And so, let's see. So we've got tubing and wire. Let's talk about tubes. That's the challenge. That's where really the
tubing and wire, of course, because you're having to maintain the integrity of an ID.
And that's where it gets the sticky part, right?
Yeah.
And I think it's important for engineers to know what they've got to make some choices in terms of what's important. So, the minute you bend a tube, there's going to be some deflection at some level. There's going to be a deflection in the tube at some level. If you bend it just a little bit, you can dive in at some magnification and you will find deflection. Maybe it's measurable, maybe it's so small, depending on what you're using to measure it, you can't detect it. But there is deflection, and so. What happens is the tighter the bend radius, especially when you're dealing with like a hypodermic tubing or any full hard tube, it's just less forgiving. And then of course, the next challenge is we want the thinnest wall possible. Again, you've now kind of accentuated the problems. But the thing to consider at the highest level of design is what's important to me. So if I've got an application that flow is important, or if I have an application where I'm trying to, I'm using it and I'm guiding something through that bend, then obviously the integrity of the inside diameter is important, is critical. And so now all of a sudden you've got the situation where deflection is a huge problem. There are plenty of applications that it's not. It doesn't impact. It does not. Obviously you don't want to kink it off. But it doesn't actually impact the application critically. They need something because they're trying to fit it somewhere that the bend radius is more important. So that's the trade-off. I can get a tighter bend radius if I'm willing to give up, or if I'm willing to accept more deflection in the tube ID, OD, if you will. And so there's the trade-off. There's tricks to minimize some of that in the manufacturing process, but they're not always scalable tricks. It's great if you want 100 pieces, even 1,000 pieces and less, but the minute it goes into production, something that's going to be used on a regular basis, they're really not scalable tricks. So there's the trade-off right early on for engineers when you're working with you can look at like an annealed tube, you can get more away with more, but that's generally different applications. When you move to a full hard, particularly a thin wall tube, which hypodermic tubing, even regular wall, is a thin wall tube in general. There's your trade-off is between the deflection that happens in the bend and the size or how big that radius or small that radius can be. So from a design standpoint, that's the kind of the first place to start. So when I say no, I look at it in its current form. It's no. It's sort of like then you guys are smart enough to go back and say it's not really no. It's just hey, we got to find some common ground here.
Yeah. Occasionally we'll get. I shouldn't say occasionally. It's frequently that we get a drawing and it's for a hypodermic tube or a wire, and it's like we almost call it a deflection versus a bend. Like it's so slight, and there are challenges with that too. Why can those very slight bends be a challenge? You're not going to compromise the ID, but why is that? And I guess. Just to take it further, sometimes it's a slight bend with a very tight tolerance, and so
that's where it gets difficult because you've got in all these, whether you're dealing with a taper or something like this, now all of a sudden you've got something that's very hard to gauge. So when it's hard, when you've got a slight bend, it's really difficult to gauge where that bend actually starts.
Yeah.
And a lot of times, you take a tube, when you call out something that's got a quarter-inch bend radius or something even really smaller. Say it's a 100 thousandths bend radius or something like that. You can kind of gauge. You can take your 200 thousandths pin gauge and put it on there and see. Oh, all right, we're there. And gauge it kind of well. And there's obviously digital microscopes and comparators that can do this. But not everybody has that or has access to that. And then when you put it into production, it's very easy to go onto SolidWorks and AutoCAD and do this.
Yeah.
And then to take it to the shop, and it's really super easy to take your tolerances and just throw them out 3 or 4 decimal places. That's very easy to do there. Yeah. When you put it into the shop and try and produce that, it's not that it's impossible. It's just the price goes up significantly, and so determining what's manageable in the application. And what's reasonable to build, when I say reasonable for a reasonable cost, and understanding that it's not even making it. It's now I've got to figure out a way to gauge it,
right,
and measure to make sure I meet those requirements,
right.
So that becomes the challenge is somebody takes something and they say we need this to be like a 3-inch bend radius on this very small wire or tube, and it's a very short angle. It's actually not that difficult to do, but then I got to find out if I did it or not. That's the kind of and I did it to those tight tolerances. Not that I did it, but I did it to those tight tolerances. That becomes a challenge.
So depending on the gauge size or the gauge size of the hypotube or the wire diameter, that obviously impacts the bend radii that we can hold, or the tolerances that are acceptable. What impact does having a multiple or complex bend structure, where there's a shift in plane or you have multiple bends? Sometimes we'll get drawings like that, and it seems like almost every part of the drawing is explicitly called out with a tight tolerance, and sometimes we have to take a step back and say, which of these are critical. Yeah. And again, that probably depends on the application but do you have any advice? How do they determine the critical specs, or how does component supply determine yes to a drawing based on the specs?
Well, again, in the design standpoint, there's the aspect of how do I design this? So let's just take something that's got a bend and then another bend. Now we've got this a straight leg. I did a bend, I got another straight leg. I did another bend, I got another straight leg of. So now I'm going to measure it, right? Well, in your design software, it's very easy to go in and say, oh, well, I'm just going to do center line to center line on those those bend radius. That makes sense. It shows well on a drawing. It looks nice. It's nice and clean. The reality is that's tough to find that. So from and forget finding it in final inspection. I'm finding it on the production floor in an in-process inspection with an operator running, a piece of equipment. So from a design standpoint, we typically, not that you can't do that, but we just throw that information out. We're going to then calculate like kind of the outside to the outside. So we're going to calculate that bend radius plus the diameter of the tubing, which is going to get us outside the tubing, and then do the same thing on the other side. So we're going to be measuring kind of outside to outside, because finding where those straight lengths exactly start is challenging.
Transition.
And so calling out these outside dimensions for the bends are very, very helpful. And then determining what's actually critical. So if all of a sudden you call that, you think, oh, okay, great, I'll call the outside of that entire length of the part, if you will, the total dimension, and then you throw a 5,000th tolerance on it, and then you add up all the other tolerances inside, you've made it not impossible, but you made it very expensive. And so that's where I think this is where I would encourage engineers as you're going through something that's like that. We have a great team who's willing to just take a phone call or send an email and just say, which one would be the ones that we should call out. These are the ones I'm really worried about, and we will take the time and say, do this, and it will be helpful from the manufacturing standpoint, and then you can evaluate whether or not we're saying, because again, we want to make it easy for us, right? You need to make it fit your application, and so we're going to tell you what's kind of the easiest. And then to produce, you've got to then go back and say, okay, but I actually need this. And we'll just work from there and find out which specs are critical and what to call out on a drawing. And again, the whole thing is at the end of the day, we want to produce something that their incoming inspection is going to look at, and we're all talking the same language on the same page.
Right. An opportunity to kind of test what is critical. Maybe you don't know. Maybe you haven't, you've seen it in the drawing, you've produced the part as a drawing, you haven't had the opportunity. It's really early stages, so you haven't seen it, you haven't gotten parts in your hands yet. One of the opportunities that Component Supply has is we have a rapid development team, CSRDT. We have a team that's dedicated to these fast turnarounds for prototypes, and especially with bends, like 1 to 5 pieces. Like, you really just want to see what's going to work. And sometimes I think that has been helpful to our customers, because they can take the real life part and then say, okay, actually, this is what was. I thought maybe this was critical, but as I'm putting it in the application, I'm seeing I can afford some flexibility here, but I really need to stay pretty tight here. And then we can do iterations of that's helpful. But that's the goal. If you're just like, I can't wait, I just need to know if this works before I want to buy 500 parts. That's a great opportunity that we quote those regularly. And I think our team just does a really good job of getting those out fast for you to test with. Well, we understand. So in this application, this situation, we've had plenty of people say, I don't think I can handle any deflection, but I don't really know. I would like to try this size tubing with this diameter bend radius, or these different diameter bend radiuses. And we'll just go out and we'll do that. We'll make those parts and send them to them. That way they've got the same tubing, 3 or 4 different bend radiuses, without trying to do anything special, that's easy for manufacturing, and they can go through and kind of say, okay, this one, number 1, that didn't work at all. Number 2, I can get away with that. Number 3 is the best. And so then they kind of say, all right, here were my parameters. I at least got it in my hands and know where the failure point is. Right. And then we can move from there. Yeah, and I think you take the opportunity to widen your tolerances when you can. That's always going to help your cost. It's always going to help your lead time. It's going to help your inspection. So we do encourage that. Not that we want you to produce sloppy parts or anything like that, but just within reason. We want it, of course, to work for your application. We want it to be as precise as possible, and we're going to try to get it perfect. But a wide tolerance does allow for more flexibility. It lets you produce the parts a little faster. So I think that those are good methods. We do this all the time. We are happy to work with you through the challenges. You know, if you're working with Custom Fab, most of the time you're going to be working with Courtney in the initial process, and she will ask you kind of some of these questions. She's good about kind of seeing where, man, I think they're going to struggle with this, or I don't think this is a cost-effective way of doing this, and try and get you to see where maybe you could be more flexible. But of course, you know, we'll do our best to maintain all the critical specs. But that's really those are the engineering challenges that we pretty much see with bending, tubing, and wire. We can do these multiple complex bends. We can do single bends, and we'll work with you through any challenges depending on, you know, the gauges, diameters, and lengths. Do you have anything else to add?
One more thing, just kind of at a high level, we're kind of giving away not really trade secrets, just but a generalization is right off the bat, if we get a drawing that has a bend radius that's roughly 4 times the diameter, we're going to be able to do that.
Yeah.
So if you have a 20 thousandths outside diameter tube, and you've got, you know, an 80 to 100 thousandths bend radius, that's not one that comes across that's a no.
Yeah.
If you have a 20 thousandths diameter tube and a 25 thousandths bend radius, that's where we start with the no, and then we start figuring out from there. Wire's a little less. You can get away with a smaller multiplier, if you will. So maybe 3 times, 2.5, 3 times. But if you're looking at a blank screen and you're starting from scratch and know that you need something bent and you're working with a full hard tube, that's a good place to start. Your application may require it to go down, and it's possible. It is possible to do that. But if you're just starting off with a blank page in the beginning of the design, that's a good place to start.
Yeah. So let us know if you need any help with your applications, with bending capabilities. We've got you covered. And yeah, I think that's it.
All right.
Go change the world.